Hello everyone. Today we will discuss design some project by using microcontroller. Okay, let's start. First, start with tell me the difference between microprocessor and microcontroller. So, microprocessor uh, is an electronics component that is used by a computer to do so its work. So it is a central processing unit on a single integrated circuit chip and containing millions of small components including transistor, register and diodes that work together. Okay, and what is microcontroller? So basically here we make a table for create a difference between microprocessor and microcontroller. So here write down parameter. Okay, microprocessor, and this is microcontroller. Okay, so first start with application of microprocessor. So application of microprocessor is like gaming, web browsing, document creation, and simulation, calculation, many more. Okay, so these are the application of microprocessor. Okay, and microcontroller basically it's dedicated for specific task. Okay, it's dedicated for specific task. Okay, like camera, example is camera, washing machine, air conditioner, and home automation, etc. Okay, these are the example. Okay, next next is here we differentiate microprocessor and microcontroller in terms of internal structure. Okay, so internal structure. So first, memory and input output devices connected externally in our microprocessor. in our microprocessor. Okay, but in our microcontroller, CPU, memory, and input output are present internally. Okay, and next term is cost. Here we differentiate microprocessor and microcontroller in terms of cost. Okay, so cost of microprocessor is high and cost of microcontroller is low or less. Okay, next parameter is power consumption. Power consumption is high and power consumption is low. Okay, in microprocessor power consumption is high, in microcontroller power consumption is low. Okay, next parameter is memory. Okay, in terms of memory, so memory is basically RAM is main memory. So here in our microprocessor, RAM memory lies between 112 MB to 32 GB. Okay, and in our microcontroller it's limited up to 2 KB to 256 kilobyte. Okay, next is storage. In terms of storage, so in this case we use a hard drives or hard disk. So hard disk memory lies between 128 gigabyte to 2 terabyte generally. Okay, and in our microcontroller we have a flash memory, and flash memory lies between 32 kilobyte to 2 MB. Okay, and next is in terms of peripheral interface. In microprocessor, peripheral interface is USB, UART, and high speed Ethernet for peripheral interface. High speed Ethernet. Okay, in microcontroller, in peripheral interfaces are UART, I2C, and SPI are present. Okay, so in our project we use a Atmega 328 microcontroller. Basically in market Arduino Uno board are present. So in Arduino Uno board this microcontroller, this is a microcontroller, microcontroller at mega 3 to 8 is fabricated here. Okay, so basically with the help of this Arduino Uno board we make any project easily. Okay, so let's so here I give some knowledge about this board. So basically this is your USB jack. Okay, so with the help of this USB jack you connect this board to computer and cell phone, and the purpose is to burn this microcontroller with hex file. Okay, so this is our USB jack, and this is your power supply socket, power supply socket. Here we give a 7 to 12 volt DC. Okay, next is this is our crystal oscillator. This is our crystal oscillator. So here we give our generator 16 megahertz clock pulse. Okay, next is this is your voltage regulator IC, voltage regulator. Okay, with the help of this voltage regulator we regulate our variable DC 7 to 12 volt to 5 volt DC. Okay, so next is this is your, and this is your at mega 16U2. Okay, basically this IC or this chip is used for USB to serial communication. USB to serial communication. Okay, and this is your reset button. Okay, so this reset button is used for, suppose you burn this microcontroller with some program, so you want to execute this our program, so you click on this reset button, so your program executed from starting. Okay, next component is this is a capacitor, and this capacitor is used for filtering purpose. Okay, and this is your pins. Okay, this is your pins. This is your analog pin. Analog pins, and this analog pin is used for to connect the sensors. Okay, here we connect the sensor, analog sensor. Okay, sensor, analog. Okay, and these are the power supply pin. This is your power supply pin. Okay, suppose you required 5 volt supply, so you connect this 5 volt and this ground. Okay, so you get a 5 volt supply. Suppose you want to 3.3 volt supply, so you connect this pin to ground. Okay, you get a 3.3 volt DC supply. Okay, so basically in this board we have a two power supply. First is a 5 volt supply, second one is a 3.3 volt supply. Okay, so two supply is present in our board. Okay, so this voltage regulator is is used for 3.3 volt supply. Okay, and this is your V in. This is your V in. V in is used for, suppose your power supply socket is not work, so you directly give a 7 to 12 volt DC with this pin. Okay, so this supply goes to this your voltage regulator, and your voltage regulator regulate the voltage in 5 volt DC and supplied to this microcontroller. Okay, and next is this is your ICSP. ICSP is your circuit serial programmer. Okay, this is your circuit serial programmer. In circuit serial programmer. Okay, and next is this is your digital input output pin. This is your digital input output pin. Okay, so here pin 0 and pin 1. Pin 0 is used for serial serial out. 0 is this 0 is used for serial in. Serial in means it's behave like a receiver. Okay, and 1 pin is used for serial out. Serial out means it's behave like a transmitter. Okay, and here 3, 5, 6, 9, 10, 11. These pins is used for PWM generation. PWM. Okay, so with the help of these pins we generate the PWM. Okay, and again this is your digital ground, and this pin AFR AREF is used for analog reference pin. This is your analog reference pin. Okay, so this is your and this is your LEDs. It's on means your power supply is come on this board. Okay, and this LED is for transmitting, and this LED is for transmitting and transmitter and receiver. Okay, suppose any data pass through pin number 1, so this LED is blinking, and this receiver pin, suppose 0 pin receive some data, so this LED is blink here. Okay, So this is all about this board. So here this is your USB cable. With the help of this USB cable, this side connect to your computer and this side connect to this board. Okay, so with the help of this type of cable, you program your microcontroller or arduino board. Okay, so this is your circuit diagram, and basically this diode is used for reverse voltage protection diode. Okay, suppose in this microcontroller any reverse voltage is flow, so this diode is block this reverse voltage. Okay, and this is your voltage regulators. Okay, and this capacitor is used for filtering purpose, and this is your op-amp. Basically this op-amp is used for compare the voltages. Okay, so it's compare the voltages of, suppose you connect the USB serial to this USB port, and this adapter is also. So this op-amp compare which one give the best voltage. Okay, so best voltage give to this microcontroller board. Okay, so in this microcontroller, its operating voltage is 5 volt, and here we recommend 7 to 12 volt for best operation, and voltage limit is 6 volt to 20 volt. You don't give above the 20 volt and don't give the below the 6 volt. In between this voltage range, it's behave like it's operate good, and if we give a low voltage or beyond the 20 voltage, so our some regulators is damaged here, so give a voltage between 6 to 20 volt. And digital input output, here is 14 digital input output pins, in which 6 pins are used for PWM output. I'm already discussed with you which pin give a PWM output, and 6 analog input pin. With 6 analog input pin we give a analog signal to Arduino board, and here DC current in input output pin in 40 milliampere for 5 volt. Suppose our DC voltage is 3.3 volt pin, its current is 50 milliampere. Okay, and next is flash memory is 32 kilobyte, and here in which 5.2 kilobyte is used for bootloader, and static RAM utilize 2 kilobyte, and EPROM erasable programmable ROM is utilize 1 kilobyte space. So discuss some project here. Open Tinkercad. Okay, so this is a Tinkercad. Click on circuit and select create new circuit. Okay, so in first project we take 3 LEDs, and with the help of Arduino board we turn on and turn off LEDs in particular or after some time delay. So it's like one LED is on, after that second LED is on, and then third is on. So it at a sequence, one LED is on, then on next LED, then on next LED. So this is a sequence. Okay, so this project is designed with the help of Arduino Uno board. First select the Arduino Uno board, click this Arduino Uno board and drag and drop. Okay, and here we require LEDs, so take LED and register and small breadboard. Okay, so basically in this breadboard, this these pins are short circuited and these pins are also short circuited. Okay, so internally. Okay, so suppose you connect in this pin, so you take output from any pin. Okay, so you get a same potential here. Okay, and this is also same. Okay, and in this is a horizontally short and these pins are vertically short. Okay, so these pins are vertically short. Okay, so this is our breadboard. So next step is, so basically in our Arduino Uno board, this is a 5-volt supply come from this USB. Okay, so click this 5-volt supply and connect to this positive supply. Okay, and change the color. Positive color is red, DC voltage, and again click on ground and click to this negative terminal. Okay, and change the color is black. Okay, and next is, so this in all we get the 5 voltages. Okay, check this voltage, take a multimeter. This is a multimeter, so this is multimeter positive terminal, connect any pin, and this is negative terminal. Okay, and click on start simulation. Okay, you get 5 volt. Okay, stop simulation, click on delete and delete, and also sort this, give a connect to negative, connect to the negative, and positive connect to the positive. Okay, so in this, so in above row we also get a 5-volt supply. Again check, positive connect to positive and negative connect to negative. Okay, okay, we get the 5 volt in all points. Okay, remove this multimeter. Okay, so next step is connect this LED, take a 3 LEDs. Okay, you want 3 LED, 4 LED or 5 LED, so here we take a 3 LED, or suppose I take a 4 LED here, so copy and paste. Okay, paste. Okay, so in this pin we connect the LEDs. Okay, okay, and change the color. First is red, so second is green, third is yellow, fourth one is orange, you take suppose blue color here. Okay, this is 4 LED. Okay, and all LEDs, this is anode, anode means positive, and this is cathode, cathode is negative. Okay, so all anode, all cathode connect with this resistance. Okay, so click on this resistance, copy and paste. This is anode terminal, connect to this terminal to this, again paste, again paste. Okay, so all cathode connect with resistance. Okay, so change the resistance value. Resistance value is 200 ohm, 200 ohm, 200 ohm, 200 ohm, 200 ohm. Okay, and next step is give a negative supply to this resistance. Okay, so in this pins we get a negative supply, connect here, and this negative supply give to this resistance, and connect to this resistance with negative supply, and connect this last resistance to negative supply. Okay, so all resistance, in all resistance we give a negative supply. Okay, and the next step is connect all LEDs with Arduino board. Okay, so first start with our blue LED. So change the color is blue. So this blue LED, color LED is connected with 8 number pin, and with 9 number pin we connect the anode of this yellow LED, and change the color is yellow, and with 10 number pin connect the green LED. Okay, change the color. Okay, and with the 11th number pin connect the red LED. Okay, and change the color is red. Okay, and after that next step is click on code. Here first step is suppose first we delete, right click and delete blocks. Okay, and define the variable. So click on variable, click on create variable. Suppose variable is LED on off. Okay, make it okay. Okay, so this is your variable. Okay, next step is take this block and drop here, and set the time is suppose 450. Okay, and next step is go to input, and in input not input, click on output, and select this set LED to high and drop here. Okay, drop here. Next is click on this control and drag this weight box here, and in this box put the variable is LED, paste here. So this is your variable and time is in millisecond. And next step is take again go to the output and drag this box here, set build LED into first is high, second is low. Okay, with this with the help of this block we create a this block is used for create a time delay. Okay, so next step is again go to this control block and drag this or directly copy or duplicate this block, and here this is your set built-in, and delete this block built-in LEDs and go to the output, and here this is set output pin block. So drag this block to here, and with the help of this pin number we give a output. So here select the pin number, start with pin number 12. 12 is set pin 12 to high, and after that give a delay. So duplicate here. Okay, high, and then after give a use a delete function, and 12 number pin is after low. So after few seconds, millisecond, it's low. Again copy, duplicate this block, and first remove this block. Okay, and again give a delay and change the pin number is 11, and after that duplicate this block and pin number 11, first high then low. Okay, again duplicate this block. Okay, and after the pin number 11 move to the pin number 10, first pin is high then low. Duplicate this block. Okay, so first high, then use the delete function, after that make it low. Again copy this duplicate this wait function, move to the next pin. Next pin is 9, pin number 9, and start with high, then duplicate high and low. Okay, so so here we don't connect pin number 12, so start with the pin number 11, change the pin numbers 11, 11, then 11, 11, then 10, 10. Okay, after the 10 select 9 and set 9 high, then set 9 low, and after that set 8 high, set it low. Okay, so this is our programming. Okay, click on simulate. Okay, our only two LEDs is blink. Okay, so here connection, here we make a wrong connection, so stop this. Basically this connect to this. Okay, here we connect with cathode, so these pins connect with the anode. So okay, tenth number pin connect to this anode, and this 11 connect to this red anode. Okay, change the color is red. Okay, and click on simulate. Okay, red, green, yellow, blue. Okay, so your LED is turn on after few second delay. Okay, and after that next step is click on code, and this is your serial monitor, and click on this download button, and this is your code. Okay, for this LEDs turn on and turn off. Okay, so this is your code opened with arduino software. So basically this is your debugger. Okay, click on moving. So this is your program. Okay, so suppose you want to implement this simulation into the hardware. First generate this code. Okay, and click on this verify. Okay, after the verifying, click on upload. Okay, so when you connect your Arduino board with computer, then click on this verify, then click on upload. When you click on upload, this program burn into our microcontroller, and suppose you make a hardware like this, so your hardware LEDs turn on and turn off according to this program. Okay, so this is the first project. Okay, let's discuss next project. Basically in next project we have a ultrasonic sensor. With the ultrasonic sensor, suppose in ultrasonic sensor we set some distance, and suppose any object lie in between range, your buzzer is give a sound, and your LED is off. Okay, first LED is on, and suppose you lies beyond the range, your next LED is on, okay, and buzzer is off and your next LED is on, okay. So this is your project. So again, in this project, select Arduino Uno board and drag and drop here. This is Arduino Uno board. Take ultrasonic sensor, write down ultrasonic sensor, ultrasonic. Take this 4-pin sensor HC SR04, okay. So in this ultrasonic sensor we have 4 pin, VCC, trigger, echo and ground, okay. And next take it buzzer, so this is your piezo type, okay. Next is take one breadboard, okay, and LED and resistance, okay. So again, in this program, first give a supply to this breadboard, okay, to connect a 5-volt VCC, first start with the ground, okay. So ground color is so here give a negative supply is black color, and next give a positive supply to this breadboard, change the color is red, okay. And next step is, this is our LED, take 2 LED, copy and paste. This is our second LED, okay, connecting this breadboard, okay. This is our resistance. So again, this cathode of resistance connect to this resistance, okay. Again copy the resistance and paste, okay. So again change the value of resistance is 200 ohm, 200 ohm, okay. And change the color is change the color is green, okay. So next step is connect this buzzer, okay, and this is our ultrasonic sensor, okay. And next step is give the supply to this pins also. So positive connect to positive and negative connect to negative, okay. Change the color is black, okay. So now give the power supply to this ultrasonic sensor, okay. So this is a VCC and this is ground. So ground connect with ground, okay, and VCC connect with positive volt, okay. Change the color is red, okay. And next is, this is trigger and this is echo, okay. Okay, echo pin connect to 5 number pin of Arduino board. Change the color is suppose this, and this trigger connect to the 6 number pin of Arduino board, and change the color for differentiate. This is purple and this is the blue. And next step is connect these LEDs cathode to this resistance, already connected, and give a negative supply to this resistance, okay. So this is negative supply, connect to this resistance. Change the color is black, negative supply is black, and this pin is connected to this. So here we give a negative supply, and this is a positive and this is negative terminal of piezo buzzer, okay. This is negative terminal, terminal connect with negative supply, and this positive terminal, and this positive terminal so this positive terminal connect to 8 number pin of Arduino board, okay. Change the color is rose pink, okay. And 9 number pin connect to the LED green, color LED with anode. So here with the help of 9 number pin, give a positive supply to this green LED. Color is green, and next is red LED. So 10 pin connect with the red LED anode, okay. Okay, so this is a connection done here. Next step is move to the coding part. Click on code and delete this boxes, drag and paste in delete box. So delete these boxes, and again first define the variable. So suppose here we define a variable input, okay. So here we define input variable, okay. So next step is go to variable and select this set input block and paste here. And next step is click on input and select this read ultrasonic distance sensor or trigger pin and paste to in this block, okay. And first set the pins. So ultrasonic sensor on trigger pin. So our trigger pin is pin number 6, and echo pin is 5. okay, unit in centimeter, okay, and paste this block to here, okay. This is our block. Okay, suppose you want to check the data of ultrasonic sensor and you want to print it. So go to output block, and in output block select this print serial monitor block and paste here, okay, and go to your variable and select input and paste here, okay, and click on simulate, okay. So click on serial monitor. So this is your data, okay, data of this ultrasonic sensor, okay. So here suppose we want to move this pointer, so your serial data is change, okay. Stop simulation, and next step is go to control, and in control take if else condition. It's a control block, okay. Okay, first close this serial monitor, okay, and okay. So this is the if else condition. So here this is a control blocks, and next step is set the limit. Next step is go to maths, and in maths this is your greater than less than box, drag and paste here, okay, and in one you put your variable is input, okay. Next step is take on condition is greater than equal to, okay, greater than equal to, and put the distance value is 100, okay. So if input is greater than or equals to 100, then here we want to output. So output is set pin number, paste these blocks, okay. So here equal to, if input means our variable is equal to 100, so set pin number here 8 pin connect to with this buzzer, so buzzer is high, so pin number 8 is set, and turn on LED. Suppose we want to turn on green LED, so green LED connect with the 9 number pin, so select 9 number pin is high, and low this is a 10th number pin, 10 number pin is low, okay. And in else condition, take this block, copy, duplicate this block and paste in else condition, and change the condition, set if in else condition, set 8 pin is low, 9 pin is low, and 10th pin is high. Okay. So in this case, this is your pointer. Suppose we change the location of pointer. This distance is changed. Here we write a conditions. This pointer come in the range of 100 centimeter. So this buzzer and green LEDs, buzzer is create a sound and LEDs is turn on. Distance is greater than 100 centimeter, so this red LED is on. So this is all about project. You make lots of project with the help of these circuits. Okay.